Okay, so in part two of this module, we look at decentralized computing architecture. So this part in the series is a continuation of this particular module. Okay, so decentralized computing architecture. So data processing and storage distributed across multiple locations or devices. So here you have increasingly important design trend impacting modern infrastructure. So this is the difference between when you have a centralized computing architecture and when you also have a decentralized computing architecture. And some examples of decentralized computing architecture examples is blockchain, P2P, that's peer-to-peer, content delivery network, Internet of Things, distributed databases, and the onion router. So for resilient architecture concept, here we're asking ourselves, how do we implement a cloud infrastructure that's going to be resilient, that's going to be very, very strong enough to withstand maybe so much of traffic, so much of bandwidth request, having clients from different parts of the world. These are the concepts we consider when we're looking at quality of service, QoS. So here we want to look at replication, local replication, regional replication, geo-redundant storage. So here you see, that's why most cloud computing services like Azure, AWS, and GCP, they will normally have data centers in different parts of the world. So this is going to help them be able to provide a very resilient architecture. Take, for instance, you have a file server or you have a computing device, especially, for instance, for a file server, and you're trying to access content from that place. What happens most of the times, you have a mirrored service, so that if one fails, you have the content from the mirrored service. And you also have servers that are in that format. You have file servers that are in that format. You have computing services that are also in that format. So when there's there's an health issue with one of the service, you have the other being presented to serve clients. Now, application virtualization and storage. So cloud containers, virtual machines, virtualizations, all these applications of virtualizations, and they actually make cloud computing very, very possible. So without virtualization, you can't have cloud computing. So cloud computing is just an adaptation, it's just an application of virtualization. Virtualization is a means in computing where you want to have one server, and that server is going to be able to house multiple applications or multiple operating systems. You have your system, and you can have a virtualization software, or we call it hypervisor. And that hypervisor is going to be able to host, let's say, Windows, is going to host Linux, is going to host any other operating system. Then you can now run your applications on those systems. So when you run a virtual machine, for instance, you understand this concept. Whereas in a containerized system, what you have is that you have a server, you have a host applications operating system. Then you have what we call the Docker engine. And with that Docker engine, you can now host multiple applications. And the good thing about a containerized system is that you don't have to be concerned about the operating system like when you look at a virtualization, right? So irrespective of the operating system, you want to make sure that you're able to run your application. So that's the clear difference between a container and a virtual machine. Now, cloud architecture, virtual private cloud. So in cloud computing, virtual private cloud is very important because you want to make sure that you provide a virtual system for each of your clients, and that's what we call VPC. On the channel, I'm going to be doing a series in cloud computing very soon, maybe sometime this month, as time permits me. I'm going to run series in for those of us that want to be taking certifications in either AWS or Azure or GCP. So these are very important concepts because it also helps you to understand the concept of security. Then, of course, we have serverless computing. Then you have what we call microservice, where you kind of have miniature components of your entire application. So it helps for you running independent services, and they can meet specific business capabilities. So all of these are ways you can actually implement cloud architecture. Then, of course, we have infrastructure as a code. For infrastructure as a code, you have a system whereby you run in your code, your provided infrastructure, then you have your code run on that infrastructure. And of course, one of the things you want to do to help you automate your system is to make sure you have a load balancer, you have edge computing. In edge computing, you have services running at various ends of your or closer to your clients. So instead of having, let's say, processing or storage or compute in a server, you have it closer to the client. And for auto scaling, this is a concept in cloud computing where you're saying, how do I make sure that if something happens, I can provide a bigger service? And for instance, for denial of service or distributed denial of service, where you have an attack coming from different places, how do you ensure that, okay, if somebody sends 10,000 requests, you can be able to handle it? And that's where auto scaling comes in. In auto scaling, you are saying, okay, I'm going to have server A, server B, server D, C, server D. I'm going to be using my minimum server requirement is going to be one server. But if something happens and I'm getting more requests, I want to scale that service, and through a load balancer, I want to balance all of these requests through all of these services I have here. It's just like saying, okay, a server can only take, let's say, 10,000 gigabits of bandwidth per month, and it receives 50,000. What happens? That server is going to say 501 error. It's going to say, I can't handle the request, or it's the request is more than what I can handle, or it's going to say bandwidth exceeded. Any of that, a 301 or a 501 error. The server is going to give you that instead of a 200 response, which is okay. So instead of having such kind of configuration, you can have such that if you have more requests than your minimum requirement, you cannot auto scale. You can now serve to the other items or server on your system. And that way you have a very responsive service. Then in software-defined networking, we're saying we don't want to, so the control, the data, and the management plane helps us to make sure that we are not just trying to control our network, maybe through doing some kind of configurations, some kind of setup, some kind of adaptations. Here, we want to use softwares to kind of define, to control, to enable, to configure, to do all of that. And that's why, for instance, you can have a router within your network, and it has a software that you can control over the internet, or you can have a mobile app, and you can log in and you can shut it down. That is a very classical and simple example of what you mean by software-defined network. You could just log into the software, you could control the data, and also the management plane. So this is the explanation here. So data plane, where you have the routers, where you have the switches, and where you have all of this. So there are some features of cloud architecture. So we have, you need to consider your cloud architecture. You need to look at costs. You need to look at scalability. Can you scale? Can you improve? Can you grow? Can you increase? Resilience in terms of quality of assurance. If something happens, how fast can you come back on track? Ease of deployment, and that's where OPEX is very crucial instead of CAPEX, instead of spending a lot of capital expenditure. How can you just, with little knowledge or no knowledge, deploy your infrastructure? Ease of recovery. Do you have service level agreement or infrastructure service agreement? Power, how do you control that? Compute. So these are the kind of the things that a cloud architecture gives to us, and it helps us to actually minimize cost. Then you also have data protection, you have patching and upgrades, because if a cloud service provider gives you a Linux system, right? So upgrading, patching, and actually securing that stays in their domain, depending on whether you're going for an infrastructure or you're going for a software as a service model. They also have secured communication. You also have secured access, because most cloud service providers are going to provide a means for you to securely, either via a software or via a CLI, connect to the cloud infrastructure. Or at times, some of them are going to grant you an API, like an SDK, like a suite that you can use to actually call into your server. So for review, we talked about deployment models, we talked about service model, we talked about the responsibility matrix, where we're looking at how do we actually, what's our responsibilities. Then we looked at a centralized and a decentralized system, and we looked at quite a lot. For the lab, we're going to be implementing containers and virtualization. So these are going to help you understand the concepts of cloud computing. So for 6B, we're going to be looking at embedded systems and zero trust architecture. So in embedded systems, you're going to say, how do you have a system in a system? For zero trust architecture, you're trying to say, how do you provide authentication into systems and make sure that you're not trusting anybody? You are giving people only another concept which you call least privilege. You're giving them only what they need. You don't trust anybody. You want to make sure that you verify and you authenticate every single person that is going to be accessing your system. So for embedded systems, you have specialized systems, and you can see them in home appliance, like your fridge, like your TVs, like your microwave, like your AC. These are applications of embedded system. You could see them in smartphones, automotive systems, medical devices, and they're going to help you provide compute service, at times storage service, at times help you to kind of understand what is happening within that particular infrastructure. Then we have what we call the industrial control system. So if you want to, and this is an adaptation of IoT, if you want to control large-scale enterprise, you want to control water, you want to control, let's say, AC system for a, let's say, a 1 hectare facility. If you want to control, what's it called? You want to control gas. How do you automate most of these things? So that's what you call industrial control systems. And you have this in a lot of developed countries where you're not just looking at IoT in a very small system where you're just trying to control, let's say, your gates, your AC, your windows within just a home, a 500 square meter facility. No, you're trying to say, okay, how do I do this in a very large scale, right? So that's where you have human machine interfaces, you have data historian, you have programmable logic controllers, you have supervisory control and data acquisition. So this is going to help you actually control GUI interfaces that are going to help you control the gas system, the water system, the AC system in a very large scale enterprise or a factory. And you can apply these systems to industry, energy, fabrication and manufacturing plants, logistics systems, and big facilities. So Internet of Things, like I said, I have a series on the playlist that talks about Internet of Things. You can look it out. I took time to I've started an introduction to IoT. I also started looking at CCTV, and I'm going to complete that series by going through the Cisco IoT, connecting things, Internet of Things, big data, and automation. So it's a series you want to look at because it's going to provide a very good introductory guide for you with respect to Internet of Things. Okay, so Internet of Things also have their own vulnerabilities because Internet of Things is simply saying, okay, I have an industry, I have AC, I have a fridge, I have a gate, I have a car, I have something, and I want to be able to control that device over the internet. If you want to control that thing over the internet, then you need a network. So this is also an implementation of a network where you want to have multiple devices being able to be controlled over the internet, and they have their associated risks. So at times they have security, misinterpreted security capabilities. At times they are unpatchable. So especially when they are rushed to the market. So some of these things, that's why you see some ransomware, you see some malwares, they infect IoT device. I want you to do a simple research by looking at IoT vulnerabilities. I think we have some of these attacks in as Cyber Ops, the Cisco Cyber Security Operations Associate. So some of them lack designs. You can see any small guy, any person can just go take an Arduino or Raspberry Pi and set up a small system that is like a robot or that is self-driving car, and or that can be able to help you do temperature analysis. And some of these systems, they are not so robust and they have their security implication. You have some guide, the IOTSF, the IIC, the CSA, and the ETSI. These are very good standards that can actually provide you guidelines in terms of standards, in terms of controls, in terms of making sure that you have a secured system. Okay, so deperimeterization, right? So you have perimeterization, then you have deperimeterization. So you have a perimeterized system where you have controls within a perimeter, within a fenced system. And this is going to shift focus from defending not just the network boundaries, but by protecting each of the digital assets. So instead of having gates, access controls, and having dogs, having a swipe card, having CCTV cameras, all of those things are going to protect your perimeter. So here you want to do what? Making sure that the data center, the systems, the softwares, the PCs, all of those things are protected. So in Zero Trust, we're saying never trust anybody, just make sure you authenticate. So you can have level 1 authentication, level 2 authentication, level 3 authentication, like that. So you can have somebody's password, you can say OTP, you can do iris, that is verification, you can do fingerprint. You want to always verify. So you have this in cloud, remote work, mobile systems, outsourcing and contracting, and you have this adapted in wireless networks. Same thing applies to these areas. Same thing with all of these points. You have that these are adaptations or implementations of deperimeterization and Zero Trust. So I've already explained the concept of Zero Trust. So these are the things we've looked at, right? Embedded systems, industrial controls, Internet of Things, and all of this. So that's all for this particular series, and I'm going to see you in lesson 7. Don't forget to ask questions in the studies room, or if you have questions, you can ask in the comment section.